My name's Kymberlee Price, and this is my first time at Philly ETE. My first time in Philadelphia, actually, and my first time at a developer conference. I speak at security conferences on a regular basis, and got contacted out of the blue to come talk to developers and thought this would be a great opportunity because when I speak at security conferences on third-party libraries, the question I most frequently get is, how can we go talk to our developers about this? So I'm going to go talk to some developers about this. So security vulnerabilities in third-party code, fix all the things. A little bit about me. I am senior director of a large red team, which is a security vulnerability testing team. It's a distributed team, similar to Lyft that you would use for crowdsourcing a ride. I have 26,000 security researchers around the world who do freelance pen test of applications, typically mobile, web, IoT applications for our customers like Tesla, Western Union, Pinterest. And that's my day job. And so that is more on the using offensive security in a defensive capacity to make products more secure. But before this, I was totally a defender. I worked at BlackBerry in the product security incident response team, and I handled open source and third-party library vulnerabilities in our handheld devices and Playbook tablet. And a lot of what I'm going to talk to you about today comes from that experience. And I have a few war stories to tell there. I do a lot of data analysis. Previously at Microsoft, I was an internet crime investigator involved in the Zotab malware and APT investigations. I've done security evangelist work, but my training is behavioral psychology, and my core fundamental personality is lawful good. So I'm going to give you a quick overview of the problem space, and because this is my first developer audience, I am going to, at various points, give you a little bit of sort of this is the security world, and forgive me if you know it already, and I'll try to move through it pretty quickly, but I want to be sure that we're speaking the same language. I'm going to take a look at 7 specific libraries just as examples of the types of vulnerability loads that you're dealing with and that you're facing in your products. And the most important part, I think, once we've gone through the why everything is broken content, is what can we do about it? And so I'm going to give you some recommendations for managing those libraries and share a case study with you because I've been talking about open source security since 2014. And people have come up afterwards, talked to me about it, asked for my slides, and actually gone and done something about it. So I want to share one of those stories with you. So open source security it can be a really hard concept to get your minds around because this isn't your code. This is someone else's code. So before we get too far into open source, and to make sure everyone's not, totally combed out from the cookies that were on break, who here is familiar with a CVSS score? Okay, a few hands. Does your company have an active SDL, Security Development Lifecycle program? Okay. Do you know who to contact at your company for a security response incident? Okay. Okay, a few more hands. That one makes me feel better. Okay. This sort of the inter-office 911. Something went wrong. Okay. And do you know how vulnerabilities are classified at your company in terms of priority rating? Okay, few. Alrighty. So third-party libraries are used in development because it's an efficiency factor. You're under pressure to develop a great product and get it out fast and high quality and not high cost, and it's really hard to manage this iron triangle of things. You can have cheap, fast, or good, but you can only pick 2. So using third-party libraries makes a lot of sense. You could take the time to write your own font parsing engine, or you could use FreeType. That's been written, updated, it's been looked at by a lot of people, it's used in a lot of applications. Totally makes sense to use someone else's code. But for all the benefits of it, there is a little something that can be missing from that, and that is security. Because if it's not your code, is it being reviewed in a security audit by your security teams? If you bring in external third-party pen testers, are they only looking at your native code? Who's responsible for the security of that third-party library that you're consuming? So what's more, even the data on third-party libraries is hard to follow. So for example, this quote from Secunia, third-party programs are responsible for 76% of the vulnerabilities found in the 50 most popular programs in 2013. That sounds terrifying. The problem is that report's flawed. They're not actually even referring to third-party libraries. They're talking about third-party applications that run on Microsoft systems. So even when you try to be informed and get data, a lot of the reports are misleading and not great. So when you're trying to manage these libraries that you're using and understand what are the risks I'm introducing, it's hard to know where to start. So you could start with a data source that's online, and this was from OSVDB, which unfortunately, just in the last 2 weeks, announced it was shutting down. Because like most open source software, it had no funding. And it was 2 people pretty much shouldering the brunt of maintaining an open source vulnerability database for the whole world to use, but there were no contributions coming in either financially or in terms of contributing product. So they ultimately decided to stop maintaining that. But as of last summer, they were doing all sorts of analysis on vulnerabilities and making that available publicly, such as this. Now, a lot of these vulnerabilities are in web applications. You're not really seeing cross-site scripting in a Windows app, typically. And a lot of this talk today is going to be stats heavy, and I'm going to try to make it applicable to multiple platforms and not just web applications. But this, you can see, over the last decade, we're still dealing with the same vulnerabilities we've known how to avoid for years. We know how to do input sanitization, but we still keep shipping code that doesn't do it. So we still keep having to patch it. And I think one of the examples of, just code has flaws, and that's how it is, that really hit the main stage for all of us, even outside of the security space, where I have friends in the security industry who were like, oh my God, my mother asked me at dinner last night about Heartbleed and if she should be worried. She doesn't even know what a browser is, but she heard about Heartbleed on the news and she's worried. And so all of a sudden, third-party libraries got a lot of attention, and they were viewed as this, typhoid Mary bringing pestilence to our applications. And the logo and the marketing went a long way. And then after that, we've got Freak, which I think should have been Super Freak, but whatever. Then there was Poodle, because SSL suddenly became very popular for security researchers to go look at. It was like, oh my gosh, Heartbleed. What if I find the next Heartbleed? That could be career-making for me. I could get the next great job. And what's more, I could improve the security of this application. So OpenSSL started getting a lot of attention. After Poodle, we've got Logjam. And then a fellow I actually first gave this talk with, Jake Koons, you'll hear me reference him or his company, Risk-Based Security, a few times. We were going to speak at DerbyCon, and then there was a Bash presentation, and I thought Bash Hole would be great. But that one ended up becoming a shell shock. And briefly it was called Bash Bleed, but it ended up being shell shock. So then we have the Drown attack. Well, the Drown attack is like SSL v2. So, a whole version back, if you're still using that, we should talk about your code hygiene. And it's pretty low impact, so we threw a life preserver on that one. And it's not just OpenSSL that's having vulnerabilities consumed by multiple applications. And we reuse our code names, apparently, for vulnerabilities. Security researchers have realized that they need their own websites and marketing programs to publicize their vulnerabilities. And so there's a vulnerability from 2013 that they called Ghost. And that was in the GNU-C library. But there was already a vulnerability called Ghost from 2005. Somebody did not do their history. So vulnerabilities are everywhere. They are all over third-party libraries. And chances are, if you're using third-party libraries, you didn't just stop at one. They're like Lay's potato chips. You're going to use an open source library, and you're going to use a lot of them. And so on the surface, it's like, okay, yeah, I use 5 or 10 or 20 third-party libraries. But let's go back to OpenSSL for a minute. And we talked about all those named vulnerabilities, bash bleed, shell shock. How many vulnerabilities do you think there have been in OpenSSL since Heartbleed? And don't use that Secunia accounting method. Like, one vulnerability is one CVE. The other problem with Secunia, and I'm not trying to bash on them, I'm trying to share my painful learnings. When I first started doing analysis of third-party libraries, I went to Secunia, and I would search for, say, all the free type vulnerabilities, and I'd get an insanely large list. And when I started digging into it, I realized everyone who consumed free type would issue an advisory. And so there could be 8 different advisories referencing one CVE that was counted as 8 different advisories. So that's why I'm saying don't use the Secunia accounting method. If you're counting by CVE, how many vulnerabilities, a CVE is a unique identifier for a vulnerability, common vulnerability enumeration. So how many vulnerabilities do you think there have been since Heartbleed? Just shout it out. 100? 30? Heartbleed's at the bottom, and I haven't updated this slide since last summer. There are 47 publicly documented vulnerabilities, and we'll come back to why I say publicly documented in a few minutes. The average CVSS is 5.23. Now, CVSS is on a scale of 0 to 10. 10 is the worst. 10 is remotely exploitable, no authentication required, complete destruction of confidentiality, integrity, and availability. You've pretty much owned the person completely with a CVSS 10.0, of which there were several of those in the last year and a half, 2 years almost now. But CVSS 5.2 is actually considered moderate class. Most companies, when they're thinking about how quickly do we need to fix things, would say a 5.2 within 120 days. It's not super urgent. The problem with CVSS scores is Heartbleed was only a 5.0, and Heartbleed was really bad. Heartbleed was an information disclosure vulnerability. Now, if you have an information disclosure vulnerability that allows me to access the photos on your phone, that's bad. If you have an information disclosure vulnerability that gives me your unencrypted username and password, that's the level of bad that Heartbleed was. And so even though the raw score comes out low, it's still highly impactful. And because of what OpenSSL is used for, that low CVSS score can be a little bit misleading. The other thing I want to point out about these OpenSSL vulnerabilities is that 10 of them had public exploit code available. Anybody could just go download and run. And at least 14 we know of had private exploit code being traded. So any of those are probably being exploited in the wild because it's easy. You don't have to even find the vulnerability, let alone write the exploit. Somebody's done it for you. Not you, you're all good people. I mean the criminal people. So given that background and the fact that we're going to assume you're using third-party libraries, otherwise this talk wouldn't be interesting and you wouldn't be sitting here. We're going to assume that you're using more than one library. So let's talk about what that really means in a real-world gut check sort of way. And to get started, I want to make it clear that doing this, all you need is vulnerability data, which you can get from a variety of places. You could go to the National Vulnerability Database, which is a federally funded offering. It's available to the public, and every vulnerability there is cataloged. Now, there are some exceptions. Web application vulnerabilities and mobile application vulnerabilities that are maybe on the server side that don't require the end user to make any updates to their systems don't generally get CVEs. It's only when the IT admin or the home user has to install a patch that a CVE is typically assigned. There are some exceptions, like Heartbleed. But again, enterprises had to install that patch, so while my mom didn't have to do anything with it, sorry, that's very gendered. While my dad didn't have to do anything with it, IT admins did, so that one gets a CVE. So you need vulnerability data, and the National Vulnerability Database is available for free, or there are a number of excellent paid sources for vulnerability data that we'll talk about a little bit more in a few minutes. You need spreadsheet software, and I would recommend a browser, but I'm into UI like that. So these are really the only things you need. You don't need big data, you don't need Hadoop, you don't need a data scientist on your team. Now, all of those things will make it go faster, but this is the basics that you need. You can have a project manager on your team go do this stuff for you. You don't even have to do it yourself. The other caveat I want to make, and this comes back to the whole public data versus private data, data from public sources is limited. What happens with the National Vulnerability Database is that the vendor contacts them and says, I need a CVE. Please give me basically a number to allocate to this vulnerability. But if the vendor doesn't do that, if the vendor silently patches something, maybe a vulnerability was found internally, maybe a vulnerability was found in their private consulting arrangement with a pen test firm, and they're not going to publicly announce it, they're just going to patch it and move on. Those vulnerabilities will never be in a public database. However, there are private databases that will do code assessment and say, okay, this library fixed 4 vulnerabilities and silently patched another 8. And here's what they do. And so risk-based security has a product called Vulnerability Database, which if you compare CVE, 191 vulnerabilities, to VulnDB, over 1,000 for FFmpeg, it would be really easy to say, come on, guys, like RBS, risk-based security guys, math is hard, I know, but 1,000 to 191, how can you be that far off? FFmpeg themselves says on their website, this advisory fixes the following vulnerabilities and more security issues that have no CVE number. So vendors openly admit they patch things without documenting them. So that's the other thing to be aware of when you're using third-party libraries, is they don't always tell you what they're fixing when they release a new library. So let's start with the poster child, OpenSSL. Who uses OpenSSL? And you don't have to raise your hand. This is the hypothetical. Gmail, Tor, LastPass, AWS, Yahoo, Tumblr, YouTube, BlackBerry, VMware, Dell, Pinterest, WordPress, tons of companies. And I got tired of looking up little icons, so we also have HP, Oracle, F-Secure, IBM, MySQL, Novell, Fortinet, Sophos, Rapid7, Juniper, like you name it. Tons and tons and tons of things use OpenSSL. So you may not be thinking, yes, I use OpenSSL, but if you use any of these things, you use OpenSSL. I've mentioned FreeType a couple times. FreeType is interesting to me because I mentioned working at BlackBerry. And in 2011, there was a FreeType vulnerability called CVE 2011-0226. This is before the fancy code names came out. I called it sleep deprivation. And this was a vulnerability in the FreeType library that was scored on that CVSS scale as a 9.3. And it was used in an application called Jailbreak Me for the iPhone. It allowed you to jailbreak your iPhones. I worked at BlackBerry. Why did I care? Because we used FreeType. And here's a vulnerability that's being remotely exploited in my competitor's platform that I know I shipped that library. And typically a jailbreak would be a terms of use violation. You're not supposed to jailbreak your device. You voided your warranty. I can't ensure your security. But because it was remotely exploitable, a missing parameter check allowed a malicious font program to push a stack pointer out of bounds. And you owned the device. That's bad. That's beyond just terms of use. That's vulnerability that needs to be fixed. Now, at BlackBerry, we had sandboxed FreeType within the browser instance. But it still meant you couldn't use the browser securely, and you couldn't read email in HTML format. Those were pretty significant problems. So here are a few of the products that use FreeType that are publicly acknowledged. The GNU library, NetBSD, FreeBSD, Android. GhostScript is on millions of printers. So it's out there on printers. It's also in OS X, WebKit. WebKit's fascinating because WebKit is a third-party library that consumes more third-party libraries. So when a FreeType vulnerability gets publicly disclosed, WebKit has to go take that update, and then you've still got to go take the WebKit update. So it's cascading your patch management. Debian, Red Hat, PlayStation, Opera. My favorite, the American Girl video game. So if anyone wants to hack your Wii or your PlayStation or your Xbox, it has FreeType on there. Anything that is trying to parse fonts using FreeType, send it a malicious font, see if you can knock it over. libpng. libpng is a graphics rendering library. We've tracked it to over 130 applications, including products from Google, Apple, Adobe. But first off, it's a graphics library and that's its logo? Like, really? Like, that's all? I think they're phoning it in, totally. So it's in Visio and PowerPoint. We're seeing libpng, a third-party library, and Microsoft products because interoperability, we want to be able to open PNG files. So there's good to be had in third-party libraries. It's in BlackBerry, VMware, the WebKit logo is up there again. iOS Flash, a bunch of Adobe products are compatible with libpng and will render libpng. Ubuntu, Slackware, Red Hat, VMware Server, tons and tons of applications. So lots of things use libpng. Speaking of libpng war stories, again at BlackBerry, I had a libpng vulnerability that I knew was going to affect WebKit, and I filed a bug with the WebKit team. And we got it patched. And then someone was like, hey, wait a minute. What about the application layer? They're telling me they don't use libpng, but I found it in like the code trace. We did a tree analysis. Yeah, if you rendered a malicious image in the Pinterest mobile app, you could own the application layer. Okay, well, cracked open another Jira ticket. And then I found a third instance of libpng on the handheld. These are all different dev teams using their own instances of libpng, using different versions of libpng, all of which were outdated, all of which required updating because of critical vulnerabilities in the library. So we're going to come back to how can you better manage that sort of stuff so that the team working on the feature in another part of your application isn't reshipping the same code that you've gone and shipped in your part. Apache Tomcat, it's used in a lot of really important things like payroll software. This is kind of a problem now. I mean, okay, so you owned my Pinterest and you can see pictures of like the cakes I want to someday be able to bake or something. But I don't want you messing with my payroll or my network or SAP, Oracle. These are pretty important things. Fedora, Ubuntu. And Flash Player. So Flash Player is not truly open source, but it is licensed by a lot of things. It's used by Apple, Oracle, Microsoft, Google, WordPress, BlackBerry, you name it. It's used in televisions. I don't know when the last time any of you updated the software on your smart TV was, but check it out, kind of like your home router. Make sure you update those regularly because they have all sorts of stuff on them that need updates. Linux, Opera. I mentioned the Sony and Logitech Google TVs. And Java. Anyone here have to patch Java on a regular basis? I decided to stop finding icons and just declare them the winner because we've shipped Java to Mars. I think that gets the most ubiquitous spread of anything. It's on other planets now. So Java wins. So let's look at the actual numbers. I've talked about where it is. OpenSSL, and other thing I want to point out really quickly, I update my data once a year in July. That is not frequently enough for you. You want to not just patch annually, but I don't patch anything anymore, and it's very time consuming. So I sit down for a week in July and I crank through 7 libraries and I update my slides once a year. So this is as of July of last year. From January to July, January 07 to July 2015, they had 90 vulnerabilities, averaging 10 to 11 per year, and they've got 3 releases per year. Now this is important. When we're talking about the vulnerabilities in the code that you use, it's not just about raw numbers. It's also about how frequently does a library update. Because if a library updates every week, that's a lot more work for you than if they're updating 3 times a year. And their average CVSS, or their average criticality on that 0 to 10 scale, is a 5.49. FreeType, they had 50 vulnerabilities. FreeType is notorious for silently patching, though. So yeah, they had 6 vulnerabilities per year that are publicly documented, but they actually have more than that. They average 2 releases per year, and they are on no sort of schedule whatsoever. So it's not like Java or Adobe, where you know it's coming out on the 2nd Tuesday of the month or the 1st Tuesday of the quarter. It's just whenever they're ready. We've got a bunch of fixes, let's ship it. And so you can't plan for that. You can't schedule it in your work cycle. And their average CVS is 7.43. A number of their vulnerabilities tend to be remotely exploitable due to malformed fonts. libpng has fewer vulnerabilities, still a low number of releases, CVSS of 6.65. Apache Tomcat has a lot of vulnerabilities, 100 in that span of time. So double what FreeType does, quadruple what libpng does. They average 5 releases per year, but their average CVSS score is really low. And the reason for this is a lot of companies will, below a certain severity rating, they don't do a public advisory. It's considered not advisory class. We don't need to spin up IT admins to worry about a really low-risk defense-in-depth fix that we've made. It's not exploitable in and of itself. It's just going to harden the stack, and let's focus on the high-severity stuff. But Tomcat documents everything. So they'll document vulnerabilities that have a CVSS score of 2.0. And so that not only brings their average severity rating down, it increases their overall numbers. So these are just contextual things that I want to point out, because when you look at the raw numbers, it could look really bad, and in context, it's not quite as bad. Flash Player, now that one starts in 2009, and that one had 522 vulnerabilities. They release roughly monthly. Occasionally, they will go out of cycle for a critical vulnerability that's being exploited in the wild. And their average severity is 8.96. I can tell you that the security team at Adobe invests very heavily in security testing. They have a public disclosure program with HackerOne. They do private bounty programs through other vendors. And they bring in external pen testers and consultants. They have an internal security team. The amount of effort they put into securing their products is actually tremendously significant, and that's part of why their count is so high, because they're finding and fixing a lot of things. And then Java. They're on Mars and 539 vulnerabilities, but they only release quarterly, which means if it's the week after they just released and a really, really bad vulnerability just came out, either they will have to release an out-of-band patch that's unscheduled, or you're not going to get that fixed for 3 months. So I think the nice comparison there is between Flash and Java. The vulnerability counts are about the same. The severity is close to the same. The patching cycles are different. How frequently are you going to need to maintain that library in your product? So if you just look at 2015, FreeType and libpng reported no vulnerabilities, but FreeType had some. I'm just telling you that right now. They had some, and they patched them, and just because you didn't see CVEs associated, you should still update your FreeType libraries if you use them. And so we can start seeing increasing trends. I like to display this data to development teams in a bar chart because unfortunately, all the charts are going up and to the right, which is not the direction we want them to go. But this is useful because when you're thinking about how am I resourcing and how am I planning this product, am I building time into the development cycle for updating, knowing what we expect to come in during the development cycle, having an idea of the historical trends will really help you make those decisions. So I mentioned earlier, Flash has a ton of vulnerabilities. Java has a ton of vulnerabilities. That means they're less secure than FreeType and libpng, right? No, it just means that they're attracting a lot of attention. If the number of people working on Flash were working on FreeType, I would honestly feel more secure in the usage of FreeType because I know anything that's in there would be found. So third-party libraries, clearly they increase efficiency because you're not having to write your own font rendering library or image renderer. But your application could have multiple third-party libraries implemented. And that's a lot of patching, not just for you, but for your customers. So I think something that frequently gets debated among security analysts is what should you measure library quality on? Is it the count of vulnerabilities? Is it the frequency of their updates? Is it the average severity, whether you use CVSS or some other scoring method? Should you just be focused on, is there a public exploit? No, it's not an or. It's the overall health of a library. And there are companies that are working on, essentially trying to create a consumer reports as for a library to give you an idea of what you're getting into. So that leads very nicely into what can we do about it? Because that was a lot of depressing data. Developers are taking more and more accountability for these libraries. And the reason for that is because customers are not sympathetic to this. They are not sympathetic to hearing, well, that vulnerability wasn't in my code. It was in code we use. Well, yeah, but it's in code you ship too. So I expect you to take care of that. And so there have been people who are saying, oh, so you're saying that open source, like this is the historical feeling that open source is supposed to be more secure because everyone can review it. Linus's law, more eyes make bugs shallow. But no one is looking at it because no one's being paid to look at it. When's the last time you did a security review of one of the third-party libraries you use? Ever? Has anyone ever done a security review of a third-party library you use? I have yet to have anyone raise their hand and say, yep. Because you've got day jobs that involve your native code. And so no one's looking at it yet. Am I arguing that closed source software is more secure? It's maintained by big enterprises. It's got people working on it. Is that what I'm saying? Don't use closed source. Don't use open source. Don't tweet that. Kymberlee said not to use open source code. No, bad code is just bad code, and it's everywhere. And bad is a generalization. People make mistakes, and code that works functionally may have hidden vulnerabilities. The reality is you're all builders. And that gives you tremendous creativity to see how to do something. But how to break that thing you've just built in a strange and creative way, like putting peanut butter in your blender and seeing if you can burn out the motor, that's what security researchers are really good at. And the number of times someone has said in a development meeting, but why would they do that? That's not what it's made for. Right? But they did, and now they're making your code do something you never intended it to. So those sorts of things just happen. So everything is broken. Let's fix all the things. How are we going to do that? And I want to set a little bit of baseline information about vulnerability management and SDL, and then I'm going to give some very specific examples of things you can do in your development, planning, and implementation that not only will make your security team love you, but give you fewer fire drills later when it comes to managing these libraries and patching once you've released something. So this is going to be small font, and I'm not going to read the whole thing to you. The link for Wikipedia on vulnerability management is there. The cyclical practice of identifying, classifying, remediating, and mitigating vulnerabilities, especially in software and firmware. Vulnerability management is integral to computer security and network security. And the first 2 paragraphs are very much about computer, software, and network. And then the last paragraph says, correcting vulnerabilities may variously involve the installation of a patch, a change in network security policy, reconfiguration of software such as a firewall, or educating users about social engineering. Nowhere in there does it say you have to check in a fix and regression test it and smoke test it and then update the UI, make sure it works in localization, and app compat. You know, it'd be really bad if you broke TurboTax this week. So it tends to end up going very network centric. And then if you go out and you search on the web for incident management process, you're going to get really pretty charts that are very network focused, where they're talking about intrusion monitoring, event correlation. So vuln management sounds like a network security issue, but vuln management starts long before you ship software to your network admins. The National Institute of Standards and Technology estimates that fixing something after release can cost up to 25% more than if you fix it before you release the product. Fixing code in the design phase is great, but you haven't written any code yet. So we're going to talk a little bit about the development process in a minute, but this is just some data on why it's better not to punt those fixes to post-release from a financial perspective. And recognizing that you have to balance time to market, hitting the market at the right time with the right features for customer uptake, sales, generate a user base, and sometimes you have to make that call of, we'll have to fix it later, but make that call wisely because it can cost you a lot of money later. Pay me now or pay me later. So the common advice coming from a security group is going to be fix vulnerabilities as early as practical, which is nice and vague, as early as practical, so that there's fewer to patch when it's most expensive. So that's easy, right? It's only security versus performance, usability, functionality. You guys have great features you want to develop that are probably a lot more exciting to your users than fixing a buffer overflow. And so there's this sense of a struggle. And frequently development teams and security teams end up being very adversarial, where security feels like they're not being listened to, maybe development isn't listening to security, maybe development is like, oh my gosh, here come those security people. They never have anything good to say. They always just tell me why I can't do something. Trust me, nobody likes incident response, and we know it. We know no one likes to get email from us. We always have bad news, but there's a lack of understanding between the builders and the breakers and how we can work together to get things fixed earlier and more easily. So it's not about performance or usability or functionality. It's about development cost and time. That's the fundamental problem. It's not that the security team is asking you to give up functionality for security. It's that we're trying to balance those priorities. And, you know, you've got to have some humor. So sometimes when you fix a bug, you create more bugs. And the security researcher that reports a vulnerability to your company, and sometimes even the security team, may not fully appreciate that. So having that dialogue where it's like, okay, we can fix that, but here's the cost of fixing that, not just financially, but we could introduce regressions. We could actually delay launch dates. Here's what's involved in testing it. And so again, improving that communication can really help to develop a partnership based on mutual respect. So if we start talking about the security development lifecycle, and wow, my slides are a lot pinker on the screen than they are on my monitor. They're purple on mine, but so we start off, and this is the Microsoft model of security development lifecycle. Sorry, I'm showing my roots a little, but it's training, requirements, design, implementation, verification, release, and then response. So there's actually part of the development lifecycle after you release your baby into the world. You still have to raise it. So some SDL models will merge requirements and design, but I like to keep them slightly separate because you can't really design it until you know what you're designing. And so where are vulnerabilities introduced? In design and implementation. And that's why threat modeling is really important, code audits. Where are they identified? During verification, and then after you release by people who are using the product. But if you use third-party libraries, where the vulnerabilities are identified, they're all being identified throughout the entire process because you don't own that code. That code is already out there in the world, being used in other products, available for download. And so it's not like it's just in your repo being worked on and implemented, and we're doing beta 2 this week, and then the test team's gonna run with it, and we'll release it in another 2 months, and then we'll start getting vulnerabilities identified. So if you design your application using libpng 1.4.2, and by the time you get to verification, there have been 8 vulnerabilities identified, and they're on libpng 1.4.6. Have you planned to update as the library updates, even though you haven't released yet? Because if you get to release and you're 3 libraries behind in versioning, you're going to ship with outdated code, and somebody's going to send you a security report that says, you're shipping with an outdated library that has these vulnerabilities. And you're going to end up having to patch it. And it's entirely possible at that point there will have been API changes, architectural changes, and now updating is more expensive, resource-wise, than if you'd done the incremental steps for each release. It may introduce more regressions. It's all being done in the public eye because people know what you shipped with, and they're going to know when you update it. So keeping that in mind for scheduling throughout the development process is really important. So how does vulnerability management compare? So vulnerability management is still a linear process for the most part. You identify an issue, you assess the impact, you dev and test the fix, you deploy the fix, then you're in the post-release phase. Patch Tuesdays right there when you deploy it. This looks just like the incident response process. Incident response, you're going to identify that issue, assess the impact, dev and test the fix, publicly release with the CVE, and then you're in the post-release phase, if you're a software vendor. But if you're a software vendor who used third-party code, you didn't find out about the vulnerability until they released it. So now, in that first step 1, hacker McHackyPants reported to FreeType that they've got a vulnerability. And FreeType assessed the impact, and they dev'd and tested a fix. And then they released it, which is when you found out about it. And now you can start your assessment of impact and your testing of the fix. And if you're an IT admin who has to go patch that vendor's product, that's where you find out about it. You're at the tail end of that. That vulnerability has been alive in your enterprise for probably months at this point. So the recommendations I'm going to make are going to be to try to tighten that up for you. So in the identify issues phase, if you don't have an internal security research team, you're going to want to probably try to find some external security researchers, either consultants. Make sure you have a disclosure policy on your website that tells people if you find a vulnerability in our software, here's how you report it to us. secure@company.com. And here's our PGP key so that you can send it securely. I can't tell you the number of times researchers have said to me, oh my gosh, do you know anyone at company X? I have tried contacting their customer service. I've tried contacting any security email I can find. I've tried contacting them through Twitter, through LinkedIn. I have a vulnerability I need to tell them about. Make it clear how people can report vulnerabilities to you. Identify what libraries you use and then monitor them for vulnerabilities. Use automated tools and analysis, static analysis, fuzzing tools, and do some crash log analysis if you have the resources to do that. Frequently, things that are causing crashes are just really poorly written exploits. There are a lot of vulnerabilities to manage, which is why you will need a vulnerability management process. And if you have a dedicated security team, I know they would love to talk to you about this. If you went and said, hey, what's our vulnerability management process? They're going to get giddy and bring like chocolate and coffee to the meeting. They're going to be thrilled. So then you want to be able to prioritize. And when you have 150 CVSS 7.5 and higher vulnerabilities, they all look the same. How do you decide which one is the most important to fix? Because you know you can't fix them all. Like, you can't. There's just no way. The vulnerabilities keep coming in. You know, you can, let's say you're only fixing 10 a week, but you're getting 15 a week. You have to decide which ones you're going to fix first. Do you go by the highest CVSS score? First in, first out, last in, first out? Is it externally known? Is there exploit available publicly? I would definitely fix the ones that have exploits available publicly first. But there's a lot of things to look at there, because intelligent prioritization will reduce your product risk, because when everything's a priority, nothing is. Now it's time to actually write some secure code, because you're in the development and testing phases. We can patch that later. Not really cost effective. The vulnerabilities are inevitable, so don't put off fixing the complicated ones. And the other thing to keep in mind is, who's responsible for monitoring those third-party libraries for vulnerabilities? Is it you as the developer? Is it your security team? Do you know who's responsible for that? If you find a vulnerability in your test team that has if your test team finds a security impact bug in your new product you haven't shipped yet, who's testing to see if that affects your in-market products? Or reverse, if your in-market product has a vulnerability that got reported to your security team, who's testing what you're working on today? So get an idea for what is your sustainment plan? Who reports what to who? How does that communication work? My next slide is, I'm going to run through the animation pretty quickly. And I'll make the slides available after the presentation, because this is not designed to necessarily be read, but as sort of like a tack it up on your bulletin board cheat sheet. In your requirements phase, define your guiding security principles. What is acceptable to ship with, and what is a showstopper? And you do this for your quality bugs. You know, if the application won't boot, that's a showstopper. Well, if I can remotely exploit you with trivial effort, is that a showstopper? Like, where does that line get drawn? Because the closer you get to your release date, the higher that bar has to go. It's just the nature of any testing and quality assurance for your release. You've got to get it out on time. You can't just keep pushing out your release date. So what does that bar look like? In your design phase, obviously you're designing for security and reducing your attack surface. But evaluate those libraries that you're using and get an idea for what the vulnerability trends are, so that you can go to your leadership team and say, we're using a library that has this kind of vulnerability load, which means we're going to be patching this 6 times a year. Do we have resources for that? Have we scheduled that into our cycle? Do we need to hire another developer? And if we aren't going to hire another developer, where are we going to make trade-offs to support this? During implementation, of course, we're going to continue with the use of analysis tools, deprecate unsafe functions. Code scanning tools can be really helpful to knowing what libraries you use where. I'm a big fan of Black Duck. I've used that previously. There's also Palamida, Sonatype, and they can scan your source code and tell you what libraries you use in what locations that have what vulnerabilities in them. So it's not a matter of monitoring mailing lists. You've got an app that'll just tell you, you've got a known vulnerability here that you want to go patch. You have in verification, continued automatic, static, and dynamic analysis tools. This is where you want to bring in pen test consultants and make sure you're updating your third-party libraries regularly. So this is just overview. I mentioned having an idea of the vulnerability loads so that you can be prepared for future workload, but getting a feel for how many are identified each month and on what schedule, what are their sources. Some products get very, very few vulnerability reports from security researchers directly to their secure@company.com email, but they get a lot of third-party library vulnerabilities, and having an understanding of where those come from. When a researcher reports to you directly, that vulnerability information is private, at least for some period of time, typically. The average is 90 days. Most researchers will give a company 90 days to fix something before they're like, okay, you're not fixing it, I'm gonna go public with it. Some researchers are more flexible. But a third-party library vulnerability is already public by the time you find out about it. So have a sense of where that vulnerability comes from. Are you consistently seeing the same kinds of vulnerabilities? Is there maybe a need for more training in dev? Is your vulnerability backlog growing or shrinking? And what's your average time to fix? And are there early monitoring processes you can put in place? Or something I didn't put on the slide, can you sandbox those libraries in a way to mitigate risk? So you're still using it, but maybe not giving it full root access to your application. Oh, low friction ways to reduce risk, there it is. If you are a network admin, I know this has been mostly developer related, and if you're responsible also for network and IT infrastructure, talk to the vendors of the products that you use and ask them about their vulnerability management process. Make it clear to them that you care about the security of their product. What libraries do they use? When's the last time they updated them? At the end of the day, nothing helped me get a security vulnerability fixed faster than if I had 5 customers asking me about the security of the product. If you, as a consumer of a product, care about security, make sure that customer knows it. So, the case study, and then we'll have a little time for questions. VMware. They have a strong security team. It's international. They've got people overseas and here in the US. And their director of security attended a talk I gave at Black Hat in 2014 with Jake Koons, who's I've mentioned earlier with risk-based security. They asked for a copy of our slides. And then they took those slides along with their security response data to their leadership team. They had a mature incident response process. They had program managers that handled the initial triage. They had engineers that did exploitability reproduction testing, worked with the development teams to identify the right way to fix it. And they were monitoring third-party libraries, but they were typically monitoring them by watching mailing lists. They didn't have an automated solution such as Palamida, Black Duck, Sonatype. And so they started adding proactive evaluation and rating and approval. So what ended up happening as a result of going and talking to their leadership team was they got given the mandate of evaluating libraries and approving them for use by the development teams. They also got the approval to implement a code scanning tool, so they weren't having to manually monitor all of these libraries. And they held an internal security conference for their developers where they had Jake and I come in and talk about third-party library vulnerabilities and interact with their development team to talk about them. Now, most of the developers that came to MooseCon were already pretty passionate about security, and they were very excited to take this back to their teams and be like, look, this is why they don't want to let us use this library. One of the things that, the other things that they did was they started adding open source software to their testing plans. Not just their internal testing plans, but when they had pen test consultants come in, they'd no longer scoped their pen testing to native code only. So if that pen tester found a vulnerability in a third-party library, they would fix it, and then they would upstream a patch. How cool is that? When's the last time anybody who uses a third-party library tried to upstream a patch? Because I've seen a lot of people use libraries and not actually give anything back there. So they started pushing patches upstream so that when the third-party library publicly announced, they already had their fix implemented. And they partnered with dev teams in a much more healthy and proactive way to have a proactive plan and a proactive cadence for patching. So it didn't always come as a surprise to the dev team when the security team shows up and says, oh, you've got to patch again. Instead of it being a surprise, they made plans to say, on a quarterly basis, we will do a security roll-up on every product, and we'll stagger them, so we're not releasing everything in the same month. But they started working in a very collaborative and proactive way with their development teams. So they've done a lot of stuff at VMware to improve their third-party library handling, and they're pretty happy with it. There's still a lot more that they would like to do and that they're working on, but they have had some really great things come out of it, as having that conversation with their leadership team and then going and working with the development teams. So. And my last slide, I do want to thank Jake. He couldn't be here today. I asked him if he would want to come along, but he's speaking at another conference, it turns out, in, I think, DC. So his company, Risk-Based Security, I mentioned, they have a lot of data on vulnerabilities. And so thanks to Jake. And if there's any questions, I'd be happy to take those.
Hi, thanks for the talk. So most of the penetration testing that I've seen has been black box. So they should be able to capture some of the third-party libraries.
So it depends on how you scope your pen test. Some companies will do black box pen test, and I've seen other companies allow researchers to have code access and do white box pen test. So absolutely, I think the black box testing tends to accidentally hit third-party libraries, whereas when you make it a part of the scope, where you tell the pen test company, I want you to test this application, here are the libraries we use in it. And let them know that if you go find a vulnerability in that library and you can repro it in my product, that counts too. It just gives them more opportunity and more creativity there.
But like, for example, for a website, the product is the website, right? So from a black box perspective, they can't tell what's third party and not. And I think the other thing is that depending on how your system is architected, if your third-party libraries are properly encapsulated, so if you're running something server-side and you capture parameters and you make sure you scrub them, you may be using some third-party library like Antler, for example, that may have a defect, but you'll never be able to exploit that. And then there are risks with just going out and just saying, hey, look, let's update all our libraries. I think there was a famous WebLogic crash that happened with Antler, where two different, like one third-party library was using a different version of Antler, WebLogic was using it and crashed, couldn't figure out what was going on. So there's a danger with just being like, hey, let's go replace all the third-party libraries, because you can make the problem much worse.
You're not just going to throw it in before your lunch break and be like, we're good. And that's why I'm saying you want to schedule it. You can't just do it off the cuff and be like, oh, there's a new release. Yeah, we can just throw that in. And so if you've buffered your development schedule, not just for everyone buffers. It's the Scotty engineering principle, but make sure you're buffering for based on this library's update history and our dev schedule, we will probably need to update it at least once before we ship. Let's make sure we schedule that in. Okay. Or potentially, make sure you're keeping up to date on that library's development before the next release, if possible. Not all libraries give that level of visibility. That's hard when there's
often 50 or 60 or so that you're using, many of which
oh, absolutely.
No one really touches because it's kind of old or dead code.
Absolutely. And that's the problem with third-party libraries, is everyone wants to use them as this sort of plug-and-play solution, but it's not really that free. There's painful costs associated.
Cool, thanks.
Yeah. I wish it were easy. Oh my God, if I could just push the easy button, that would be awesome. But.
Thanks. So when you're using third-party software, like something that's open source, but it's distributed by your operating system vendor, let's say it's like a CentOS or Red Hat distributed package, what are your thoughts on whether or not, like, a CVE is released? Like last year we had, there was an HA proxy vulnerability. The upstream source had a patch within 2 days. It took Red Hat, to go through Fedora and Red Hat and then to CentOS, probably 2 to 3 months before that patch was released and backported. So what are your thoughts on, like, how valuable it is to, we could have compiled from source, right? And but then we're responsible for every time the upstream releases a patch to do that, and we might break something in the underlying system that the engineers at the operating system vendor are more familiar with. So, like, how do you weigh the risks of waiting for the upstream OS vendor to provide a patch for something that is in an application that you're using in production?
We had that problem at BlackBerry where, especially in WebKit, we would point fix something, but then because we point fixed, we've basically forked. And we would only do that for the most critical issues. Because of what you explained exactly, it creates all sorts of weird dependencies and regressions. And our risk tolerances at BlackBerry were not high enough to say, yeah, we'll take the 2-day check-in versus waiting for the vendor to fully test and basically put their stamp of approval on it. What we would have done, and what I would suggest, is call that vendor. Like, have a weekly email and be like, where are you at? I care about this. And if you apply pressure to them, this sounds terrible, but if you drive up their support costs, they are incentivized to get that fix out to you. And they may even be willing to give you look, we've integrated a fix, it's in testing now. They may be willing to let you test a private, because then you can give them feedback on it. But again, it comes back to your risk tolerances, and that's going to be different for every company.
Great, thanks.
We're starting an enhancement of our own security policies at our company, and we're looking at IBM AppScan with their second level, their second tier of source code scanning, and that source code scanning includes jars. Okay. Do you have a list of vendors we ought to look at as alternatives just to compare AppScan capabilities, or give me your opinion of AppScan as to how capable it is and how up-to-date its database is?
I have not used AppScan. I evaluated Palamita, Black Duck, and Sonatype, and when I was at BlackBerry, because we were in a situation where we had shrinking headcount and shrinking budget, and I needed to automate as much as I could because we were having layoffs, fundamentally. We ended up going with Black Duck because of the level of scanning and the level of detail it provided us. We were also able to integrate it with VulnDB from risk-based security and automate our case open. So we were able to pull from VulnDB the libraries we cared about, match it up with Black Duck, and it would tell us exactly what we needed to fix where. And so that was what we liked. I would take a look at those three because unfortunately I'm not familiar with the IBM solution. All right, I think that's it. Thank you so much. You've been lovely.